All right, so the focus of this lesson will be on making graphs, whereas the last lesson was more reading the graphs. So what I have here is a table showing the time it takes to create a number of copies on a photocopier. Most of the table complete. And the first thing I want to do is complete the table and then make a sketch of this. So first, to complete the table, I need to try to see what the relationship is. And I think the most natural thing is to look this way and see what's happening as we go this way. And as I go this way, I can see I'm adding 15 every time. 42 minus 27, or 57 minus 42, or 72 minus 57, it's always 15. So I'll just add 15 again to each of these. And then I can complete my table. So 72 plus 15 is 87. Plus another 15 is 102. All right. And if this was not a linear relationship, then it would be different, and perhaps I would not have enough information to complete the table. All right, so with that said, now let's create the table of this. So first of all, I want to determine what's going to go on my x-axis, my horizontal axis, and what's going to go on my vertical axis. We want to put what we call the independent variable on the x-axis and the dependent variable on the y-axis. So what does that mean? Well, quite often there's a sort of almost like a cause and effect relationship here, but quite often one of these two variables, and I have number of copies and I have time. Those are my two variables, number of copies and time. And quite often one depends on the other. So if I look at this, if I were to ask you, how long does it take to make copies on a photocopier? Well, it depends. And what does it depend on? It depends on the number of copies. The time it takes to use a photocopier depends on how many you have. So in this case, the time depends on the number of copies. So whatever the dependent variable is should go on the y-axis. And like I said, the time it takes in this case depends on how many copies you have. And so the time is what goes on the y-axis, because it depends on the number of copies. So I'm going to put time over here in seconds and put number of copies here. And sometimes it's quite clear about what depends on the other. Sometimes it's not so clear. Sometimes, and it all depends on the relationship. Quite often, time actually goes on the x-axis, I meant to say. But in this case, the time it takes depends on how many copies you have. The more copies, the more time. The less copies, the less time. All right, so next, and when I got that, after I have that set up, I want to think about how to set up my scales. And however I set up the scale of my horizontal and vertical axes, it has to be set up in a way that shows my data well. I don't want to have it all squished into one point, or I don't want it all shooting off the page. And it should have a consistent scale. So let's look at number of copies first. 10, 20, 30, 40, 50, 60. I want to, besides, instead of starting at 10, I want to start at 0, just because 0 isn't a good number to start at. And then looking at my sort of scale here, maybe let's see, if I go 10, 20, 30, 40, 50, 60, yeah, they use it quite well. So I'll set it up like that. And if I want, I could add another. If I had it compressed into every grid line being 10, 20, 30s, and so on, I'd only use up half my graph, and that's not a good way to use my space. Okay, what about time? Well, time goes up to 100, past 100. So let me see what I have here. My initial reaction is to maybe think of making my y-axis go up. First start at 0 again, and go up in tens. If I did that, I'd have 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. And that's pretty good. Yeah, my last one of 60 seconds goes a little bit past it. But that's a nice, going up in tens is a nice, easy kind of scale to visualize. And I'm using my grid quite nicely. All right, so now I just want to plot these points best I can. So 10, 27, 10 over, 27 up, roughly right there. 2042, roughly right there. And I will say, since I can see this relationship is linear, I know these points should form a straight line. The only reason they may not form a perfectly straight line is because I am kind of estimating exactly how high these are. But if I make a mistake, it should be quite clear. 30, 57, so about right here. 40, 72. 50, 87. And the last one should go off a little bit above 60, 102, so about right there. All right, now that said, I have a ruler, so I'm just going to draw kind of a straight line through this. All right, and that line I drew kind of makes the pattern more clear that it's a linear relationship. There we go, that's a big step done. And the key parts were figuring out what goes on the x and y axis. And again, whatever goes on the y axis should depend on what's on the x axis. And again, the time it takes depends on how many copies I'm going to make. Then we have to set up our scales in a way that uses the space well, but not shooting way off or being overly compressed. And then we have to go up by even amount. I'm going up by 10s for every 2 here. I'm going up by 10 for every 1 grid line here. And then if I set it up properly, my graph should fill up the space quite nicely. It shouldn't all be compressed into one side or shoot way off the page. All right, so with that said, let's use this to answer a few questions. Predict how long it would take to make 15 copies. All right, so 15 copies I can see is right here. And so if I look right here, I can see roughly it's between 30 and 40. So between 30 and 40 seconds. And so right now my estimate from looking at the graph, and this is an example of interpolation, I'm looking between points I was given, is about, I don't know, 35 seconds to make 15 copies. What I can also do is look right here at my table and realize 15 seconds, it should be halfway between 27 and 42. And remember what I mentioned from the last lesson, it's always useful to know if you ever want to find halfway between two values, you can always just add them up and then divide by 2. So if I take 27 and 42, add them together, and divide by 2, I get 34.5. So my estimate of 35 is pretty good. And so I'll say just here, I'll still say about 35 seconds. When I calculated it, again, I got 34.5, really half a second. I'll go with 35 seconds. Predict how long it would take to make 100 copies. So this is extrapolation. I'm going beyond here. So for this, I could use the graph, and 100 would roughly be, here's 80, 90, 100. And looking up here, I'm up to about here if I continue this pattern. It's getting tough to estimate with any degree of confidence, but I'd say about 150-ish, 150 seconds. That said, I can be a little more accurate, and without relying on just this visual that goes so far past, by realizing, okay, I already knew the pattern is 15 seconds for every 10 copies. So that means from here, I'd want to add 15 4 more times if I want to get to 100. It's still extrapolation. I'm just using the table, look at instead of the graph so much. So again, if I want to go from 60 to 100, I have to go up 10 4 times. And every time I go up by 10, I add 15. And so 15 times 4 is 60. And so if I add 60, I can see it'd be 162 seconds. And I feel a little more accurate about that. I feel better about that than what I did by looking at extending the graph, because I was extending it so much. It's still extrapolation, but I was again about 162 seconds. So 2.5 minutes, kind of. And then predict how long it takes to make each copy. Well, for this, again, my graph is not so helpful, but the table is. I've already seen several times that it takes 15 seconds to make 10 copies. Right, go from here to here, I'm going up by 10. Well, that means one copy is 1/10 of that. 15 divided by 10 is 1.5. So I can see by looking at some proportional reasoning here that it takes about 1.5 seconds to make each copy. And so, determine a linear equation that describes the relationship between time and the required to make n copies. So t for time, n for copies. So if I look back at my graph, the number of copies, I can put the variable n here. I'll put t for time right here. Maybe I'll clean this up a bit. I got a bunch of stuff going on. Okay, so how can I find an equation for this? Well, think back to an earlier lesson that if we want, in general, if something is a linear relationship, and this is definitely making a linear relationship, you can always write the equation in this form. Y equals ax plus b. Well, a few things. Instead of on my y-axis, I have time. On my x-axis, I have number of copies, so I'll change it to an n. A is the average change. In this case, it's 1.5 seconds. 1.5 seconds on average for each copy. So I now know it's going to be t equals 1.5 times n plus, what was that b? B was the starting amount, or the fixed amount, or the initial amount. Now you may be tempted to say for this that your starting amount was 27 seconds. But that's when you made 10 copies. We want to think back to 0. And so for this question, this last step, if I want to see the last part of my equation, and we saw this from a previous lesson, it's actually going to be beneficial if I could think back one step, imagine 0, and continue my pattern this way, and subtract 15, which gives me 12. Which may sound strange at first. It looks like that means to make 0 copies, it takes 12 seconds. But really what that tells me is it takes 12 seconds for the machine to warm up and get ready to start putting out the copies. But again, if we want to find our equation using that y equals ax plus b, we need to find the average change per one. I've done that. That was 1.5 seconds per copy. But we also need to find our starting amount at 0. And then we never actually were told that from the table. We can also see from the graph. If I look right there where I'm drawing that little orange line, that looks like it's about 12. I now know it is 12. That is my 0 amount. And so to finish off the equation, I'd say 1.5n plus 12. 1.5 being the average time it takes to make each copy, 12 being the starting amount, the time to make 0 copies, or really the time it takes for the machine to warm up and get ready to spit out the first copy. All right, so notice how we're connecting things back to earlier lessons. Again, a lot of connections here, but a good place to stop.